This lesson is Advanced Algebra Lesson 6-9, Complex Numbers. We just finished talking about Lesson 6-8 with imaginary numbers, and so we need that knowledge in order to talk about complex numbers. Complex numbers have both a real part and an imaginary part. Typically we put the real part first, so that just represents any number. The second part needs to have an imaginary number to it. There'll either be a 1 in front, or no number, or some number that would be considered a real number. Once you put a real number and an imaginary number together, it will have these two separate parts, and then we call that number a complex number. The lesson today is to illustrate how to deal with complex numbers when you're adding and subtracting, when you're multiplying, and later on when you're dividing. We'll start with the easy part, trying to add complex numbers. When you're adding a complex number, you add the corresponding parts together. What that means is you add the real parts together and you add the imaginary parts together. So on this example, we'll add the 5 and the 6 together to make 11, and then we will add the 7i and the negative 2i together to get 5i. Our answer is still a complex number with the real part at the beginning and an imaginary part at the end. You'll behave differently when you deal with a problem involving multiplication. You'll handle it very similar to just a regular problem involving FOIL. You'll multiply all 4 products together like you normally would on a FOIL problem. So we're going to multiply 5 times 6 to get 30, 5 times negative 2i to get negative 10i, 7i times 6 to get 42i, and 7i times negative 2i to get negative 14i squared. Remember, as we learned in lesson 6-8, I squared is equal to negative 1. So we're going to modify that number to become not only negative 14i squared, but negative 14 times negative 1, which becomes a positive 14. So now our problem has some like terms in the middle where the i's are located, and it also has plain numbers, which are also like terms that can be added. So the 30 and the 14 can be added together. We should put that in the front because that represents the real part of our answer. So our answer there becomes 44. And then the imaginary parts are also like terms, so we can add those together. So there we get negative 10i plus 42i is 32i. So our final answer is still a complex number. The final problem that we need to cover in lesson 6-9 is dividing complex numbers. You are not allowed to have an imaginary number on the bottom of a fraction. You're not allowed to have it in the denominator. So you must use something called a complex conjugate. A complex conjugate is not that complex. All it means is if you're working with a complex number that has an addition sign between the real part and the imaginary part, the complex conjugate for that is going to be the same values but with an opposite sign in between. So in our example, 3 plus 4i is our complex number in the denominator. The complex conjugate of that will be 3 minus 4i. If we decide to multiply the bottom of the fraction by its complex conjugate, we need to do that on the top as well. The reason for this is 3 minus 4i divided by itself basically just becomes the number 1. You can multiply numbers by 1 because nothing changes about their value. Now we're going to go ahead and do FOIL on both the top and the bottom. I'll represent the top in green and I'll do the bottom in a different color. And then we'll combine the two results when we're done. So I'm going to go ahead and do FOIL on the top. I'm going to get 15 minus 20i minus 6i plus positive 8i squared. Keep in mind that again, I squared is the same as negative 1, and I have common or like terms in the middle. So my 15 and my negative 8 over here add up to make a 7. And my negative 20i and my negative 6i in the middle add together to make negative 26i. So this is my answer for the numerator. And I've done that in green. Let's go ahead and do the bottom now in purple. On the bottom, I'm simply going to do FOIL. 3 times 3 is 9. Then I get negative 12i on the outside terms. The inside terms become 12i, and the last terms become negative 16i squared. But remember, I squared is negative 1, so that will turn that negative 16 back into a positive, and that will combine with the 9. So positive 16 plus 9 is 25, and then I have like terms in the middle. Negative 12i plus positive 12i actually cancels each other out. So now my numerator is just a number. Excuse me, my denominator is just a number. And that is what I wanted. Since imaginary numbers are not allowed in the denominator, I wanted the denominator to become just a number. So now I'm going to put everything together. My numerator was 7 minus 26i. And on the bottom, when you multiply a complex number by its complex conjugate, the i's in the middle will cancel, and the I squared will turn this number to its opposite, leaving you just with a number. So now we've simplified the problem by eliminating any imaginary numbers on the bottom.